Hey everybody, this is section 5.82, applications of exponential and logarithmic functions. And so today we're going to focus on log. So we've got an example. They give us, in the textbook, they give us this really interesting example of s of t is equal to 80 minus 62 log t plus 1. This is a formula, this is a relationship about forgetting. You take, the students are given a test, and maybe you can relate. You're given a test, and the class average is an 80%, and then over time, if you give them a test, the same exact test, they remember less and less and less, until eventually they remember nothing at all. So perhaps you can relate. Like after 18 months, if you are given a test and then you're giving the same test 18 months later, maybe you might, on average, remember absolutely nothing at all. That's what this curve is saying. It's a logarithmic curve, and so students are logarithmically forgetting percentages of amounts. Or they're forgetting, their scores are going down by a logarithmic amount. So part A asks here, what was the average score originally, and after 1 month, 9 months, and after a year? So originally, you can see here what I've done is I used Desmos to build a table. I typed it in, it gave me a beautiful graph, and then originally it's at 80, and then 1 month it's at 61%, 9 months it's at 18%, 12 months is at 10.9%. So just input-output table. Desmos is really good at doing that. And if you have a handheld calculator that you're going to use for standardized tests, then I can show you how to make a table and plug in the function and a table and a graph. On an AP test or at SATs or ACT, that's a core function of your calculator. You've got to be able to go equation, table, graph on your calculator and like zoom in to some sort of standardized window. Big trick on the SATs and ACTs and even on AP tests for calculus and such is to give you a function that's so big or so small that you really can't see, or so transformed to the left or right that you can't see it on the original standard window. Like, let's say, I think most TI calculators would be able to see this exact graph right here because it goes, like, you'd be able to see this point. But a larger graph would be outside of the original standard window. You'd have to zoom to see any part of the graph. Part B asks for you to graph the function for positive t values. And then a deeper question is, after what amount of time will the average score be 20%? So we write out the formula, and the output should be 20. Let's figure out what the input is right here. As a first step, you can see I subtract 80 from both sides, divide both sides by negative 62, and then we've got this a fraction equals a log. And so I can translate this from log to exponential form. This is the... So therefore, what that means is this is actually the exponent. Then the base is 10 because it's unwritten. We assume it's 10. And then this is the power of t plus 1. So moving it all around, you get t plus 1 is equal to base 10 to the 60 over 62. The negatives cancel out. You can type that into a calculator after you subtract 1 to get t by itself, and you get about 8.3 months. So that's a fun little example. I hope maybe you can relate to it. That that unless you practice those skills day in and day out and keep on going back to them, that you basically logarithmically lose information at a very quick rate. That's my experience with stuff that I learned in high school and college and haven't used and practiced. I just want to take a moment right now to say that one more thing that my kids love to eat right now is peanut butter and apples. Hey, do you like eating peanut butter and apples? It's yummy, delicious. We've got here pH of substances. So this is actually taken from chemistry. The pH scale is almost something that's like a commonplace. We use pH all the time. But most people don't know that it's, even in chemistry, it's kind of glossed over often, that the pH scale is actually a logarithmic scale. It's defined mathematically based on the concentration of moles. So like this input right here, H plus, is, and these brackets, they mean moles per liter. Those are the units on the input. And so how many so moles is just the number of ions per liter. how many moles do you have in a liter of water, or in a liter of, in this case, mouthwash? So if you have 6.3 times 10 to the negative 7 moles of ions in 1 liter, then you take the negative log of that, and you can type that into a calculator directly if you want. But if you want to do it by hand first, just to simplify things a little bit, like you could just stop right here. You don't have to do these extra 3 lines, and you can type it all into a calculator and hit enter and get 6.2. But I thought it'd be interesting to just take a look at this for a moment and split up. You've got multiplication here, so it becomes multiplication, and you distribute the subtraction. So this is minus log of 6.3 plus a negative or minus log of 10 to the negative 7. This negative 7 comes over, and this 7 right here is responsible for a bulk of the answer. It came from the exponent here. So really the most important number between 6.3, 10, and negative 7 in coming up with the answer is actually the negative 7. 6.3 affects it a little bit, but you can see here it has this strong of a concentration because it's that because we have these, because of the exponent here. Anyway, in part B, we know that it's a pH of 2.9, so we put that over here, and we have to solve for H+. I first multiply both sides by negative 1 to get the log all by itself. Once the log is all by itself, then you can translate it to exponential form, so you get the power, the base 10, and the exponent is negative 2.9. Rewriting it like this, you can type it into the calculator and get something like this. Negative 1.3 times 10 to the negative 3. Again, you can see the negative 3 is very close to the actual pH. 3, 2.9. That determines as a strong determiner for what is the moles per liter. So that's all we're going to talk about today. Look forward to seeing you in class.